Hello again to your chemistry lesson. In this one we will look at mass and moles. Okay, so we've already seen that when I look at a molecule, or sorry, an atom is whatever size the atom might be. If I consider that atom, the atom's mass lies in his nucleus. So inside its nucleus there, what color is going to stand out? Yellow. Okay, inside its nucleus we have protons and electrons, and even though they don't make up the biggest volume, they make up all of the almost all of the atomic mass. Okay, so if we look at our periodic table, here's our periodic table. There we go. In our periodic table, our relative atomic mass is here at the bottom of our, or approximate relative atomic mass, at the bottom in this periodic table. And I want to just explain to you, where does this atomic mass come from? What does it really mean? Is it really grams? How is it possible that when we think of an atom, that it could have 63,5 grams? Okay, now in order to understand where this relative atomic mass comes from, we need to first understand what is Avogadro's constant. So we first have to look at Avogadro's constant. Okay, now Avogadro's constant is a number. If I talk about Avogadro's constant, I'm talking about a number of things, and this is the number. It is 6, it's a decimal, in scientific notation, 0.2214179 times 10 to the power of 23. Okay, that means this comma is going to move. It's not a decimal number, it is a natural number. 602214179, and what is this? 1 2 3 4 5 6 7 8, and another 15 zeros. Okay, it's a big number, a very big number. Okay, this is called Avogadro's constant, and it specifically relates to the number of molecules, or number of, number of molecules or atoms. It depends on what am I talking about. What substance am I referring to? It can either refer to the number of molecules or the number of atoms in 1 mole. Okay, in 1 mole. In other words, 1 mole is 6 quadrillion, whatever that is. I don't know what it is, but anyway, it's 6,022144179 times 10 to the power of 23 molecules or atoms. Okay, so if I take 1 mole of an element, if I take 1 mole of an element, I will have 6,022144179 times 10 to the power of 23 atoms of that element. Okay, so if I say I have 1 mole of hydrogen, then that means I've got 6,022144179 times 10 to the power of 23 atoms of hydrogen in my hand, and that will have the atomic mass on the periodic table. Okay, do you understand what I mean? In other words, if I look at hydrogen, hydrogen has an atomic mass of 1. That means if I have 1 mole of hydrogen, in other words, I've got 6,02214,179 times 10 to the power of 3 atoms of hydrogen, I will have 1 grams of hydrogen. Let me write it like this. 6,02214,179 times 10 to the 23 atoms of hydrogen will equal 1 mole of hydrogen will equal 1 grams. Okay, technically the relative approximate, if I weren't rounding so much, it would be 1,01. I'm slightly more accurate, but I think this table only goes to 1 decimal place. Okay, so 1.01 grams, that would be the atomic mass of hydrogen. Now let's look at another example. Okay, so for example, 6,0221417 19, sorry, I didn't put the 1 there, 19 times 10 to the power of 23 atoms of oxygen. Okay, that will constitute to 1 mole of oxygen. And oxygen has a relative approximate relative atomic mass of 16. Okay, 16 grams. Okay, so if I were to look at 6,022141719 times 10 to the power of 23 molecules. Okay, so I'm not talking about an element anymore. I'm now talking about a combination of elements, and I want to look at molecules of water, H2O. That will be 1 mole of water. So 1 mole of water. Okay, what will be this things, and now I can't call it atomic mass anymore because I'm not working with atoms in my mole. I'm working with molecules in my mole. So this time this was atomic mass. Now I will call it molecular mass. Molecular mass is just how much does 1 molecule of 1 mole molecules of water, how much mass is that? Okay, now in this case we have, you can see we've got 2 hydrogens and we have 1 oxygen. So this one's molecular mass, 1 mole of hydrogen needs 2 moles of water, 1 moles of water needs 2 moles of hydrogen and 1 mole of oxygen. In other words, this one's molecular mass will be 2 of these, so 2 times 1 gram plus 1 times 16 grams, which gives me 18 grams. So let me just say that again. If I were to look at the water molecule, okay, which looks roughly like this. Okay, a water molecule looks roughly like this. 1 oxygen and 2 hydrogen molecules. And if I were to take this and look at 6,02214,179 times 10 to the power of 23 of these together, that's a lot of molecules. Okay, they will all add up to only 18 grams of water. Why? Because there will be 2 moles of hydrogen, and there will be 1 mole of oxygen, 2 hydrogens. Moles of hydrogen is 2 grams, 1 mole of oxygen 16 grams, so that the total of this would be 18 grams. It is literally basic addition and multiplication, so it's really not very difficult. But in the next video I will show you how would we use a reaction and moles and mass together to work out how much will be produced in a reaction given a certain amount of reactants. Okay, so I hope you enjoyed this lesson, I hope you learned something, and I'll see you in the next video.